solve a problem like this right here. Typically what's done is we factor. So what we're going to do is, remember when we do factoring like previous chapters or previous courses and stuff, what we've done is we moved everything onto one side to get it equal to 0, and we factor out what we can. Now what you want to be careful with is not to divide through by the trig function. So I don't want to necessarily divide both sides by cosine. I'll show you why in a minute. So let me do it the correct way. So what I would do is I would take and I would move over my cosine just like that. Now I'd factor it out. I suppose what you could do is we could do some canceling here, but I'll show you in just a second how it's going to work. So I've got cosine theta times, now this is just going to be tangent theta minus 1. Now because I've got multiplication between things, here's one of the things, here's the other thing, and it's equal to 0, I know that then we can set them equal to 0 and solve. Okay, so I've got equation number 1 here and equation number 2. So this right here says that theta is equal to the arc cosine of 0, or what angle gives me a cosine value of 0? Well, we know that that angle is pi over 2. But there's an infinite amount of angles that give me that, right? So if I go ahead and I draw this out, cosine is 0 right here at pi over 2, but it's also 0 at pi over 2 plus 2 pi, right? So pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, okay, plus another 2 pi, which would be 9 pi over 2, so on and so forth. Also, in the other direction, at negative 3 pi over 2, right? If we go back this way, and then if we continue going, we'd be at, let's see here, negative 7 pi over 2. So there's an infinite amount of angles that answer this question right here, okay? But we only need the angles between 0 and 2 pi for the first part. So for the first part, the only angles between 0 and 2 pi that establish that, or that satisfy that, is going to be pi over 2. And nothing else, right? Because 5 pi over 2 is already too far out. So there's only one guy that works for this. Now let's take a look at this guy over here. So this guy right here says that the tangent of an angle is equal to 1. Therefore, the angle is equal to the arctangent of 1, or the angle is equal to 45 degrees, or pi over 4. Okay, so it's this angle right here. But it also is this angle back here. Now you might say, well, wait a minute, arctangent's not defined over there, but remember, we're the ones that introduced arctangent. Okay, so arctangent is restricted to quadrants 1 and 4. However, because we're the ones that introduced it, we have to remember that there's other guys out there that are possible solutions. So pi over 4 is a solution to this equation. Also, so 3 pi over 4, 4 pi, 5 pi over 4 is. Okay, and so on and so forth. So pi over 4 is a solution, and 5 pi over 4 is a solution as well on this interval. And that's it. So the answers are pi over 4, pi over 2, and 5 4. Now let's go ahead and check those out graphically. So what I'm going to do is just type in cosine x times tangent x, okay, and I want that to be equal to cosine x. Now I'm looking specifically at the interval from 0 to 2 pi, and so what we want is where these guys cross, and where they cross is at pi over 4, 5 pi over 4, and there should be something else in there. Hang on, let's go back and look. So cosine times tangent is equal to cosine, and I got an answer of pi over 2 out. Let's check why pi over 2 is not showing up. Could have went like this. Give me a second here. Ah, I see it. So maybe you saw it earlier, but let's take a look here. When I go plug pi over 2 back in here, it works here and it works here. However, tangent's not even defined at pi over 2. So pi over 2 cannot be used. That guy can't be used. Now look at, I would have missed that had I not graphed it. So it was good that I graphed it. Now if I go back to the graph, I wonder if pi over 2, I'm just going to go back to the original, just so that we can see it the way that I had it in there. At pi over 2, the cosine's defined. Up here though, even though we have a mark here, even though it's saying that it's defined, okay, it really isn't, because tangent is sine over cosine. Let me show you why. Okay, so what I'm saying here is that this guy right here, okay, this guy right here, if I plug in pi over 2, this guy is 0, this guy is undefined, and so that's not a solution because we can't even plug it into the original. Okay, so there's a problem there. We can't even put that guy in. Okay, so it's not a solution. So I'm just stuck with these two, pi over 4 and 5 pi over 4. Now what's odd to me is that Desmos is telling me that I actually have a point there, which isn't the case. Okay, the way that it's originally defined. Okay, so that's not true. Now, you to find these guys from negative infinity to infinity, what we have to do is we just have to look at these two guys right here. And we have to add or subtract 2 pi to them, because those guys, so this guy did not work, this guy worked, and this guy worked. And so we would just subtract or add 2 pi to this guy or this guy. Or another way we can do it is we can just say, well, pi over 4 plus a multiple pi, because we go pi, 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 pi. Keep hitting those. So pi times k, where k is an element of the integers. So that's how we go ahead and we solve one of those guys. So just be careful. Make sure that you move everything over and then you factor. If you don't factor, okay, well, let me show you what happens if you don't. Okay, we end up with something that doesn't work. Let's say we had cosine of theta times tangent theta is equal to cosine theta. Well, if we divide through by cosine, we just get tangent theta equals 1. Now in this case, that'll solve us down to the right answer. However, if we used a case like this, sine theta times tangent theta equals sine theta, and we divided through here, we would still get tangent theta is equal to 1, and we'd only end up with these two solutions. But watch, this guy actually has more solutions. So if I switch this to sine, look at all the solutions that show up. Okay, and you would have only gotten this solution and this solution. However, you end up with this solution and this solution. This solution, no, because I didn't include it in my interval, but you end up with more solutions here. Point being is, if you divide through instead of factor, you can lose solutions. We would have lost this solution had it worked with this, but it didn't. So on this one, we didn't lose any solutions, but that just happened to be the way the problem was laid out. But you might lose solutions if you're not careful.